Hey, welcome to math. This is Mr. Jorgens here. Excited to do some math with you today, our first math lesson. Today we're covering section 1.1, which is on solving simple equations. Just so you know, as we do these videos, I'm going to put some questions in there for you guys. So as you're going through the video, be ready to answer those questions. As they come up, they'll be based on the stuff we've been talking about. So make sure you're paying attention to the video. That way you can answer the questions correctly. So our first section is all about solving simple equations. And really solving simple equations is all about something called inverse operations or inverses. And what inverses are is two things in math that undo each other. And we have lots and lots and lots of inverses. But the main ones that you know about so far and the ones we're going to talk about today are adding and subtracting and multiplying and dividing. So the reason why adding and subtracting are inverses is because if you take two numbers and add them together, say 5 plus 3, we'd get 8, right? And then if we do the opposite of adding 3, or the inverse of adding 3, which is subtract 3, then we're going to make it back to 5, right, where we started. So those are inverses. They undid each other, right? Subtracting 3 undid the adding 3, and I made it back to my original number. The other pair of inverses that I have is multiplying and dividing. And multiplying and dividing are inverses for the same reason. If we start with a number and then multiply and then divide, we'll get back to that original number. So for example, if we took 5 and multiplied 3, we'd get 15. And then if we divide by 3, since I multiplied by 3, I'm just going to divide by that same number. 15 divided by 3 takes me back to 5. So same way adding and subtracting are inverses, multiplying and dividing are also inverses. Today we're going to use those inverses to solve equations. So what you need to know is if you see addition, that you're going to undo addition by subtracting it because adding and subtracting are inverses. If you see multiplication, you're going to undo that by dividing because they're inverses. Same thing if you see division, you're going to undo it with multiplication. If you see subtraction, you're going to undo it by adding. The first example we're going to look at today is x plus 3 equals 10. So for the example x plus 3 equals 10, what that question is really asking you is it wants you to find some number where if you add 3 to that number, it'll make 10. So think to yourself for a second what that number could be. Some number plus 3 to make 10. And most likely, a lot of you guys are pretty smart. If you think about it for a second, try 5 plus 3, that's 8. So I need to pick a bigger number. Right? You'd probably realize, okay, 7 plus 3 makes 10, right? So that number has to be 7. And so when you get to the homework problems, you're probably going to be able to answer a lot of the questions doing it that way, just by guessing. But as we go throughout the year, the problems are going to get harder and harder, and you're not going to be able to guess anymore and get the right answer. So today, a big part of what we're doing is really practicing this process of inverses. And I mentioned the process of inverses on the previous slide. Now, in this problem, I have x plus 3, so some number plus 3 that's supposed to make 10. Now, since I'm adding, what we need to know is that adding and subtracting are inverses, right? So instead of just saying 7 plus 3 makes 10, so the answer is 7, instead of just doing that, because we could do it, I'm sure you can, but it's going to get harder, and we want to build up our skills, so when it's harder, we know how to do these inverses. We're going to think about what's the opposite or the inverse of adding 3. And the opposite or inverse of adding 3 is subtracting 3. So another way I can get to that number 7, usually when I solve these problems, I draw a straight line through my equal sign just to kind of keep things balanced. Because the opposite of adding 3 is subtracting 3. But if I subtract 3 to one side of the equal sign, then you're also going to have to subtract 3 to the other side of the equal sign. And I know they teach you it this way at the junior high. So if you went to the junior high, you've done this before. So the opposite of adding 3 is subtracting 3. So that kind of undoes itself, and we're just left with x on the left-hand side. And on the right-hand side, I have 10 minus 3, which makes 7. So it's just another way of getting to that answer, right? 7 plus 3 makes 10. So it makes sense as my answer. Okay, a second example we could have here would be x subtract 4 equals 11. And remember, the way that you're going to think about this is instead of x, which is a letter, sometimes that's a little confusing, we're going to think of it as some number minus 4 equals 11. Now, again, we could probably solve this a different way if you want. I think it's good to build the skills. So think about what number that would be, that if you subtracted 4, you would make it to 11. And we're going to check it in a second here. But we're also going to practice solving it by a process of inverses, because that's really what we're trying to learn today is how do we do this process of inverses. Now, in order to do the process of inverses, we're going to have to think about what operation or what math sign I'm dealing with. Do I have add, subtract, multiply, or divide? In this case, I have subtract. So since I have subtract, I know that I'm going to be doing the opposite of subtraction, which is addition, right? So instead of subtracting 4, I'm going to undo that or inverse it by adding 4 onto both sides. When I do that, 11 plus 4 makes 15. And we're just left with x on the left. So hopefully some of you were able to kind of guess that before, right? Because 15 subtract 4 makes 11. So that number that we're trying to find would be 15, right? 15 subtract 4 makes 11, right? If we check our answer, that works. I want to look at two more examples, 3 and 4. In these two examples, we're going to use that same process of inverses, except this time we're going to use multiplication and division instead of addition and subtraction. So if we look first at example 3, 7x equals 56. It's a little bit hard to tell which operation is there, whether it's add, subtract, multiply, or divide, because there's no math symbol there. It's just 7x. So you've learned this before at the junior high, but if you don't remember it, if you see a number right in front of x, like 7x there, that means there's kind of like an invisible multiplication dot there in between the 7 and the x. And so that means 7 multiply x, or 7 times x, equals 56. So if you think to yourself for a second, you can probably think 7 times some number makes 56, right? So we can think about 7 times what would make 56. So probably a lot of you guys realized that was the answer. But if you didn't, we can undo that multiply 7 by dividing 7, because multiplication and division are inverses. So the opposite of multiplying 7 is going to be dividing 7. And one way we can show division, instead of showing division by this symbol here, sometimes we can just show it by like a fraction bar, because fractions and division are related, and we'll talk about that later on in the year. But dividing 7, one way we can show that is by putting it over 7 on both sides. And that kind of means 7x divided by 7 and 56 divided by 7. Since multiply 7 and divide 7 are inverses, we're just left with x on the left. And then 56 divided by 7 makes 8. So we're left with x equals 8. And if we check to see if that makes sense, because remember, this problem means 7 multiplied by some number equals 56. So if we check to see if that makes sense, 7 multiply 8 does make 56. So it works as an answer, just like hopefully when you took a second to guess before, you would have thought of the number 7 times 8 makes 56. Our fourth example, example 4 over here on the right-hand side, is going to deal with division. So again, I kind of brought it up in example 3, but that fraction bar there means divide. So it's another way of writing that division symbol. So we can read that problem as some number divided by 3 equals 6. And again, if you think about it for a second, what number divided by 3 makes 6, right? If you really got stuck, you could try some options, right? 12 divided by 3, that makes 4. So I'd have to pick a bigger number than 12, right? And eventually, if you tried it, you'd probably eventually get to 18, right? Because 18 divided by 3 makes 6. So when we get to the answer in our problem, 18 should be the answer. And if I get something other than 18, I probably made a mistake somewhere. Now, I can undo divide 3 by multiplying 3. So the way I'm going to write that is x divide 3 multiply 3. And again, I'm going to use that dot as my multiplication symbol. And the reason why I want to multiply 3 is divide 3 and multiply 3 are inverses. So when I multiply that left side by 3, I'm just left with x. But our rule in math class is that if we do something to the left-hand side, we must also do it to the right side. So if I'm going to multiply 3 to the left, I also have to multiply 3 to the right. And 6 multiply 3 makes 18. And 18 makes sense as our answer because originally 18 divided by 3 does make 6. All right, so you should be working on some of these problems in your breakout rooms now. I'm going to be moving between the groups. And if you're stuck on this, make sure to ask me a question on it. And we'll continue with some harder equations tomorrow.